Hello everyone, so now we are going to discuss about NAT and later we will see this COPP also, but now we will focus on the NAT. NAT we already learned in our CCNA level also, so we will have the same topic, some more extra thing we will learn here. So first of all, NAT we are saying, but now we will discuss first ACL. Okay, ACL, NAT both we learn in the CCNA level, but in CCNP level also we have the ACL and we have the NAT. So first we will look the ACL. So let's see, ACL stands for Axis Control List. ACL stands for Axis Control List. And why we are using the ACL? We use the ACL to select the traffic, allow the traffic, deny the traffic. So we need to remember ACL is nothing but Axis Control List. We use the ACL to select the traffic, allow the traffic, deny the traffic, going from one router to another router. If I take blackboard, imagine, let me take blackboard, imagine I have one router here. This is a router R1. Okay, and I have another router here. This is a router R2. Example, I have one server here. This is a switch and we have one server here. And here I have one more switch. And here we have some client, maybe this is a PC1. PC1 want to access some data from the server 1. And we have one more PC, PC2 we have, and PC2 want to access some data from the server 1. So our, what we can say, the traffic will flow in this way, right? It will go from the PC1 to the switch, then it will go to R1, then it will go to R2, then switch 2 or switch 1, then again server 1. So what we can do, we can select this traffic, we can select the traffic and we can allow or we can block the traffic with the help of ACL. ACL is used, this is the key point we need to remember. ACL is nothing but Axis Control List. ACL is nothing but Axis Control List. We use ACL to select the traffic or to permit the traffic or to deny the traffic. So we can do three things with the help of ACL. We can select, we can deny, we can permit. Okay. So we can say it is a layer 3 security. Why we can say layer 3 security? Because we are selecting, we are allowing, we are blocking. So that's why we are calling this is a layer 3 security also. And how ACL is going to work? How ACL is going to work? It is going to work from the top to down in the sequential order. Example, I write here, imagine if you remember when we are in the university, we are studying, that time we learn C language, Java and C++. We are writing some code in the order like step 1, step 2, step 3, 4, 5. We are executing the code, so it is going one by one. It will execute this, then it will go here. Or in Python language also we are doing. And we can use for loop, different loop, while loop. But now in the ACL we need to remember, whenever we configure the ACL, it will execute from the top to bottom. So this is top, this is bottom. So it is going to execute from the top to bottom. So first it will come, it will check the first condition. If it is match, he will not check the second condition. Okay, he will come here. Example, we configure the ACL. Traffic is coming, so they will check the first condition. If it is match, it is allow or deny, they will perform this and they will not go for the second, third, fourth, fifth condition. If it is not match for the first condition, it will go to the second condition. If it is not match, it will go to the third condition. If it is still not match, it will go to the fourth condition. If it is still not match, it will go to the fifth condition. So now we need to remember how ACL is working. ACL is working in the sequential order from top to bottom. Because when we are going to write the ACL, we need to remember this. It is going to execute from top to bottom. Example, here maybe in the first condition you will block. Okay. In the second condition you will allow. Or let me give opposite example. I can say you have, maybe this is your office and you have your security guard standing here and you are saying if PC1 traffic is coming, allow him. First condition you give this one, allow. Second condition you give, deny. So first the security guard will allow that guy. So he go inside the PC1 traffic. Then you will say block that one. So but already the traffic is gone. So this way we need to analyze. When we are configuring the ACL, we need to analyze this way. We need to remember whatever we write in the sequence, they are going to execute in that one. First we are asking to allow them. Then again we are saying the deny. So first already he allow. So that traffic are already passed the router. Now we cannot block. So we need to look in that sequence to block or allow. We will do the lab, so you will have more idea. Just I am giving you overview about this one. So what we can say, we can allow or we can deny or we can select the traffic, and we need to apply the ACL on the interface. We need to apply ACL on the interface. If the condition is not matched, they will destroy the packet. So let me show you. We have the standard ACL. We have the extended ACL. We have two types of ACL. Let me show you here. Standard, extended, and also we have one more time-based ACL, but we don't have in our syllabus this one, time-based ACL. Now we will focus on this one, standard ACL, extended ACL. So now we will say we have the standard ACL, extended ACL, and it is again divided into two types, that is name and number. So if you are configuring the standard, again it is divided into two types. We can say this is a name or we can say this is a number. And we have one more extended ACL. Here again we have two types. If you write for the extended, we have the name and the number. So now we need to remember, we are going to check what are the advantage we are getting in which one is good, where we can use. We are going to look that one now. So now just we need to remember standard, extended. These two are the ACL. In standard again two category, one is name, one is number. And in extended again two category, one is name and another is a number. We need to remember this point. Standard ACL should be placed near to the destination. Extended ACL should be placed near to the source. So these 2 points we need to remember, because when we are configuring this one, we are going to use this. Now just remember, destination means where we need to go. Example, I have one router here. This is R1 and this is R2. I need to go from here to here. So this guy is known as source and this guy is known as destination. This router we can call destination, this router we can call source. So whenever we are configuring the standard, we need to configure near to the destination. Means here we need to configure. Imagine you have one server here, you want to go to this server, and imagine you have one client here, this client want to go from here to here. So we can say this client is source and here the server is the destination. So what we are saying, if we are configuring the standard ACL, we need to configure near destination. So destination is here, this router is near, so we will configure in this router. And other thing what we can say, if we are configuring the extended ACL, then we need to configure near to the source. This is a source, near means this one, near to the source. So we need to configure here. How we will do? First we will create the ACL globally, then we will assign to the interface. So we have two steps here. We will create the ACL, then we need to apply the ACL. We are going to see that one. Now we are discussing only theory, so we will discuss that one also. Let's see what is the difference between the standard ACL and extended ACL. So if you see here, standard ACL is nothing but it is coming in the range from 1 to 99 or 1300 to 1999. Like whenever we are creating, example, I will create axis list and I will give the number. Example, if I want to use the number ACL, if I give 1 or till 99, that will come under this category. If I write here 1, 2, 3, 10, 20, 30 till 99, this will come under standard ACL category. Or if I use 1300 till 199, it will come in the standard ACL. If I write here 100, imagine if I write 100 here, ACL axis list 100, then that will come in this range. That is extended ACL. So just we need to remember, from 1 to 99 or 1300 to 199, that will come under standard. And if it is 100 to 199 or 2000 to 2699, that will come in the extended ACL. So we will see when we do lab, you will have more idea When we do lab, you will get more idea about that one. Here what we can say, can block a host or network or subnet. We can, what we are saying, by using the standard ACL, we can block host, network, subnet. Host means one PC. Network means complete PC, we can say complete network, or subnet, particular subnet. Maybe we can say 192.168 1.0 should be blocked. 192.168, like what I want to say, I will say 192.168 1.0 block, that is subnet. Or if I want to say 192.168 2.0 should work, this is subnet, so we can allow. If we say block complete network, all the subnet will be blocked. So we can do this by using standard ACL. Same thing we can do here also by using extended ACL. We can block a host, network, subnet, but here special thing is service. Separate services also we can block here. Like I can say this guy can access the, this guy can access the server, but he cannot ping. I cannot do here, but I can do that here. Means, let me repeat again what I am saying. Here I can play with the services also. Here if you block, everything will be blocked. Here you can select what service you want to block. Maybe I can say, imagine if you are sitting here, maybe you are a PC1. I can say PC1 can access the google.com, or if your company server, you can access but you cannot ping, or you cannot access the website but you can ping. We can play with the services, like we can say he can do HTTP is a port 80, but he cannot do HTTPS, that is a port 443. So this we can allow, this we can block this, or we can do anything with the extended ACL. But standard, if you block, it will block complete. Okay, let's do lab so you will have more idea. Now here I wrote filtering is done based upon only source IP, where in standard ACL, whereas extended ACL filtering can be done by the source or destination or protocol or port number, etc. So we have multiple option here. We can select depending upon which service we want to allow, which service we want to block. We can select by using the extended ACL. Here all services will be blocked, whereas here we can select the service which we want to block, where in the extended ACL. So depend company to company, depend requirement, what you need to perform, we can use this one or that one. Okay, so when we do one lab, we will have the idea. So let's do one lab. Okay, so what we will do, we will use the EVNG, because some of our student is facing the issue, they have some issue how to use the EVNG, but I think that guy is not here. Anyhow, I will show here so he can watch the video. See, just double click here, it will open the VMware workstation. After that you need to select where is your EVNG, where you install. Example, this is my EVNG. Click this one and power on the virtual machine. When you power on, it will open, it will take some time, and it will give you the IP here. Okay, you will get one IP address here. You need to take that IP and type in the browser. Okay, you need to take that IP and type in the browser. So we can open the browser. Okay, you can open any one browser, and you can use any browser. You get the IP here, so we can type the IP here, 192.160.2.190. Whatever IP you get here, in this place you need to type that IP here. Okay, so you will get the login detail here. You need to write here what we can say, admin and EVE. Username is admin and password is EVE, and press enter. So you launch in the EVNG dashboard. You can close here and you can check here whatever folder you have. You can click here, you will see there is a folder here. If you want to create the folder, write the name here and press add folder. Example, I will write here test and press here, so you will have test folder. Then click here and go here, click any lab here like test and click here, so this file will come in the test folder. So like this way we can do. if you want to organize in the folder way. Okay, if you don't want, you can select that folder and delete this way. So now we are doing here, so I will go in the CCNP. Okay, this one I think we will use the CCNP, and here I will create the lab. I will write here ACL. Okay, ACL lab, ACL lab, and just press. If you want to give the description, task, what you are using, you can write. That is optional, you can leave, no issue. Press this one and then right click and select the node, whatever node you need, how many nodes you need, you can select here. Generally, mostly we are using here only router and switches and the PC. So how we will select the router? This is the router, this one, this one, this one. You can take any one. I am using this one. So you can select how many number of router. Example, you need 2, select 2, and whatever name you want to give, write that name here. Example R. If you want to change image, you can change image, or if you want to take same image, take same. If you want to increase RAM, you can increase, or if you want to add any interface, you can add here. Example, if you are having low interface, you can add that one, and then press OK. So you will have 2 router. Then what we will do, we will connect this router. Example, here to here I connect 1 router. You will get the interface here. You can select which interface you want to connect. This is R1 interface. Choose the interface for R1. I am using F0/0 for R1, and for R2 also F0/0. So this way we will have. And after that, if you want to use the switch, right click, click node again, and this is the switch, this one IOL. Go here, right here SW, how many switch you need. Example, you need 2, select 2, and this image is also good. You can change image or take this one, this is good. And here this one 1 GB RAM they will consume, one switch will consume 1 GB RAM. Here you can change the image, write S and press. You will have the S images like switch or whatever you need, you can select. And here if you want to increase port, you can increase. In one port, that is one interface, you have 4 port. One card is having 4 port. If you don't want to use more number of PC, keep like this. So you will have 4 port, you can easily connect, and press OK. So you will have the switch here. You can connect this switch here and if you want, you can connect from here to here also. Switch will from here to here. So you have 2 switches, one switch here, one switch here. And after that, what we can do, we can take 2 PC just to do the lab. You can take 4 PC, 10 PC, no issue. We can use Windows machine, we can use Linux machine, whatever we want we can use, like Windows. But if you take a Windows, it will consume 4 GB RAM. So it will take lot of RAM. If you don't have RAM, or if you don't want to use, you can use normal PC, that is VPC, because just we need to check ping is working or not. So we can use this one VPC. Or if you don't want this VPC, you can use router also. We can make router as a PC and router as a server also. So let me show you how we can make router as a PC or server. I will take router. Okay, I will give here the name as a PC. I will take 2 PC, and slot I will take fast Ethernet here, and image I will change here like PC image. So I can select any image here, or let me write PC or computer. C I will write here computer, C, or desktop or something, laptop. Let me take laptop, no issue. So this is the 2 laptop came here. Okay, I can say this is a 1 laptop here, and here if I want to change the name, I can change the name also. Example, this is a PC1, I will give here. This is PC1 here. Example, I want to make server, or let me connect 2 PC here only, no need to worry. We can take 2 PC here. This is a PC2. Just I am giving example. We will do lab here for the ACL, basic ACL we will do in this case only. Okay, so now we have 2 PC here. I will take one more server here. We can install the, what we can say, Windows Server 2018-19, but no need, just we need to ping. So take router, we can make router as a server also. Okay, so press server, which one you need. Example, you need web server. Okay, so this is a web server, and here I will give, I need only one, or let me take two, and here I will increase the interface. Okay, so that's all. I taken this two web server. This is router only. We will configure this one so it will work, just we need to ping, but by looking it look like a server. And you can change here whatever you want to give the name, you can give name here. Example, we can say web server. Web server, I will give this name web server, and here we can give this different name, payroll or HR server, anything you can give, no issue. So now everything is good. Our topology look little attractive. If you want to change this image, you can change look, maybe this one. Let's see how it look. Okay, anything you can keep, no issue. Let me take this one. Anyhow, let me use this one. So what we will do, we will start the topology configuration. We will write. Now let me do the IP schema also. We can use this one topology for number of times for different labs. Okay, so now let me write the IP schema. IP schema we can use anything. I will write 192.168.12.0/24, and here I can increase this, and let me make bold. If whatever color you need, you can select that color and save. So this is the IP schema between these routers, and after that we can take here, in this one we can take 1.1 this side. Okay, 1.1, and the other side we can use the other one. I will take this one, I will do here. Okay, here 2.1. Okay, this is a basic IP schema whatever we plan before. We use already this one. Here will be 1.2, and here also 1.3, 1.3 here, and here will be what we can say 2.2, 2.2 here. Okay, this one, this is a gateway, and I will move this here, that is 2.3. let me make here, this is 2.3. okay, now let's start the configuration. So what I will do, I will take the notepad here, just basic configuration whatever we done from long time, and let me start the routers, this all, so it will work. So no need to wait for this all devices to be load. Everything will start now. Let me start here, this one also start here. Let me start. It will take how much RAM it will take here, this two router 1 GB, this 1 GB, 2 GB, this 3 GB, 5 GB RAM is going to consume. Okay, here it is taking 5 GB RAM. Let me open the console of R1. Okay, let me write no and press enter, so it will load. Take the console here, write no and load, and let me go here. Switch, no need to do anything for switch. PC, this one, take the console and write here no and press. For this laptop also take the console, write here also no and yes. Same thing here, the web server, take the console and write no here, and take the second web server, write here also no and press enter. So now let's start the configuration. What we can give here, which lab we are doing, we are doing the, I think the standard ACL. Let me see here, this lab on standard ACL, access list numbered 1, this one we are going to do. So I will keep this heading here. So let's start the configuration. R1 configuration here, enable config t host name R1. Okay, and then what we need to do, we need to write here interface fast Ethernet 0 by 0. We will write IP address, whatever IP you want. I will give 192.168.12.1 255.255.255.0, and then we can write here no shut. Okay, so this is this interface we assign the IP. Let me copy paste, so we will do very fast. I will move this here, and here we will take fast Ethernet 1 by 0, this one, and here this will be 1.1. okay, so this is okay. Configuration for R1 is okay. Now we can go for the R2. So let me divide this page, and I will paste the configuration for R2. R2 is this one will be R2, here also R2, and if you see here what else we have, this side 12.2, fast Ethernet 0 by 0 will be 12.2, and 1 by 0 will be 2.1, so this will be 2.1. okay, this is just we assign the IP address to the router. After that, what we can do, we can go for the we need to do routing protocol also, because if you see here, we need to get the routes also. If we look here, we will not get this route in this router, and if we stand here, we don't know anything about this side also, because directly connected only we know. This router is directly connected here, so this information only, whatever we have, this information this guy will have, this guy will have, but this router don't know anything about this network, and this router don't know anything about this network. So what we need to do, we need to do the routing. So this information will go to this router, this information will go to this router. Okay, so which one, any routing protocol we can do standard, that is static route we can do the dynamic routing protocol, we can use RIP, we can use OSPF, whatever routing you want, you can do that one. So let me write the OSPF as we are doing. OSPF 1, interface fast Ethernet 0 by 0, IP OSPF 1, area 0. Okay, then we will write interface fast Ethernet 1 by 0, and then we will write IP OSPF 1, area 0. I hope this is clear. What we are doing here, we are writing router OSPF 1, and then we are looking this interface, going inside that interface and saying IP OSPF 1, area 0. Here we use the process ID 1, so we will use same number here, and we are putting this interface also in the OSPF, so we are writing here also, we are going inside that interface and writing IP OSPF 1, area 0. Okay, this already we learned when we done the OSPF. So I will copy here also same thing, because we are using same interface. If you see 0 by 0, 1 by 0. So with this one we enable the OSPF in the both the router. So this guy can ping this guy. Okay, and this guy can ping this guy. Everything will start working. So first of all, let me paste this configuration in the R1. I will go here. Where is the console? Here. So R1, this is the R1. So what I will do here, let me make big screen. I will paste here. Okay, I will paste here. You can see if we get any error, anything we need to correct. Nothing, no error, everything is good. So R1 we finish. Now I can go for R2. So I will copy this one and we will go for R2. This is R2. Let me make this big and we will check here in the R2. Let me paste here. So I paste everything here. So no error, nothing, everything is good. Now they will exchange the route. Okay. Now we need to assign the IP to this PC1 and we need to put the gateway. So what we need to do here, two things we need to do here. For the PC1, PC2, web server, HR server, we need to do, first we need to assign IP, second we need to assign the gateway. Gateway will be this for this network, this one, and this is a gateway for this machine and this machine. Okay. So how we will assign the IP? If we are using virtual PC, VPC, directly we will assign. But here we are using router. Okay, we are using router. Our wish, we can use anything. I am showing you how we can use router also as a PC or server, because in the coming classes we are going to do this one, this types of scenario. When we are using EVNG, we will make that router as a server. When we do the firewall or any other firewall, we will use the same concept. So I am teaching here, so you will have more idea about that one. So what we will do, let me write here, this is the auto configuration is finished. I will divide this page. Now we will do the PC1 configuration. Okay, but here we need to do special configuration. Why? We are using the router, but if we are using normal PC, easily you can do. So what configuration we will do? Same thing, as this is a router, so we need to do the same as we do for router. Okay, we need to check which interface. If you see this interface, fast Ethernet 0x0 here, so we need to write fast Ethernet 0x0. We need to write IP address. What IP we plan to give? 192.168.1.2, then 255.255.255.0, and we will write no shut. Okay, this way we assign the IP, but we need to create the gateway also. We need to give the gateway. So how we will give gateway? We need to write the default route, IP route 0.0.0 0.0.0, then we need to give this IP 192.168.1.1. so we can write here 192.168.1.1. okay, so this is a configuration for the PC1. But in real scenario, just your window PC will be here, just you need to assign IP. I am using router here, that's why I am assigning the IP to this interface, and I am pointing the default route towards this interface. Why? Because I need to send the traffic to here, so that is a gateway. Okay, so let's go here for the PC1. This is a PC1, so I will paste the configuration in the PC1. Just click right, you will get the configuration. So here everything is good, no issue. Now we can copy paste the same configuration for PC2 and other PCs also. So let me paste here. Okay, let me divide this notepad here, and here I will write the PC2. Here also PC2 IP we told we will give 3. Okay, this one, and remaining configuration remains same. This is the IP and this is a gateway. Okay, so I will copy this one, I will paste this in the PC2. So I will go here, this is a PC2. Let me make big here, and I will do here. Why, what happened? Not coming. Let me copy again. Maybe we did not copy this. Okay, let me paste here. Okay, so everything is good here also. Now we can go for the servers, how we can configure the server. So I will paste here, I will paste the configuration, same thing here. I will make this as a web server. Host name I can give this web server here, this one, and here I can change this as a 2.2, and here the gateway will be 2.1, so this will be 2.1. okay, this is a web server, this server configuration. Just we are assigning the IP and giving the route. This is a fast Ethernet 0x0. So I will copy and I will paste this in the web server. This is a web server. Let me go here, I will paste here. Okay, this is a web server, everything is good, no issue. Let me do for the HR server also. So I will go here, let me divide this page here, and I will paste here. I will write here HR server. Here will be HR. This is the HR, so IP will be 2.3. okay, gateway will be same for that one. So I will copy this HR. I will go, where is the HR server? Here I will go here, I will assign this. Okay, so I paste, everything is good here. Now we can start and we can check it is working or not. So let's see here what we are getting. Okay, everything is good. What I can do, we can test. How we can test? Just I want to access this server. Imagine here we are getting the, what we can say, duplex mismatch. If you remember, our router is half duplex and switch is full duplex. That's why we are getting this error. Nowadays you will not get this error because all the devices are full duplex, but here in the simulation we are getting. So what we can do, we can go to the all router. This is also router, this is router. Go to all router. change to full duplex, or go to the switch and put all ports as a half duplex. Any one thing we can do. Even if we did not do anything, it will work. So let me do here. In switch it is easy, I think. Just we will go in the global configuration interface, range E0 by 0 dash 2, right? Dash 2 or dash 3. We write duplex half. Okay, I put duplex half, so we will not have the issue now. Let's see, in R1 we are getting before what we are getting. If you see here, switch is having the full duplex before, but I think now you will not get, because I make the switch as a half duplex. Let me do same thing for this switch also. So here I will go, I will write enable config T, host name is the switch 2. I will write interface range and E0 by 0 dash 4, maybe 4 or 3. How many interface we have here? 0 dash 2. So let me make this is 2, and then I will write duplex half. Okay, so now I change to half, so now we will not have the error in the HR or the server side. So let me go here. Now we should not have the error. If you have seen, we are not getting any error here. Okay, so now let's start working. This is the router, so now I need to check what I need to check. I need to check PC1. PC1 should I will make little small so you can see the topology also, or let me move this up. Okay, so now you can check here. This is a PC1. PC1 want to communicate with the web server. Okay, so how we can communicate? I will write ping 192.168.2.2. okay, when I ping, it is working. If you see, a reply is coming, or if you want, I can write here repeat 100 times. Okay, so if you see, it is working. PC1 is pinging to web server. Okay, if you want to ping the other server, that is HR server, that is 2.3, it will work. Okay, what I done, from PC1 I pinged web server, then HR server, both are working. If you want to do the same thing for other PC like PC2, so let go. This is a PC2. I want to check for the PC2, so what I will do here, this is my PC2. I will make this screen small. Okay, so let me do here ping 192.168.2.2. it is working, and if I write 2.3 also, it will work. It is working, right? So what I can say, our both PCs are working. PC1 is also working with this server, and also it is working with this server. Now imagine your manager told PC1 should not ping any one server. Okay, PC1 should not ping this server. Example, your manager told you PC1 should not work for web server. So how we will do? We will use the ACL. How we can configure the ACL? Let me write here, or here. What we can write here? Let me write here aim or objective. Aim block PC1 to access web server. Okay, by using standard ACL. Standard ACL. Okay, this is the what we can say. Your manager told you block the PC1 to access the web server by using the standard ACL. Okay, this is the scenario your manager give you. So how you will block? First of all, you need to look standard ACL, and you need to remember, when we are saying standard ACL, we need to apply near to the destination. Let me show you. If you remember, here we told when we have the standard ACL, we need to apply near to the destination. If you see this one also, implement close to the destination. And if you see this one, standard ACL should be placed near to the destination. This point or this point, implement close to the destination. So what we will do, we will see who is source, who is destination. This guy want to go from here to here, right? So this is source and this is destination. So this guy want to go from here to here like this. So we can say this is near to the source, this is near to the destination. So what we will do, we will apply the ACL in this router because standard ACL is applied near to the destination, near to destination. So this is the destination here. So we should apply here. We will figure out in this way. Okay. And traffic is going inside the router and leaving here out, going outside the router. Okay, this is the flow of the traffic. Traffic is going like this, going inside to this router, leaving this router, going into this router, coming out to this router. So now let's start the configuration. How we will configure. So configuration is very simple. What we need to do standard, and we know we need to configure in the R2. So we will go in the R2. Where is the R2 configuration? This one. And now our manager told apply the standard ACL. So what we will do, we will write axis and dash list and then put the number. What number you can write any number, but you need to remember standard. If your manager is saying standard, then you need to remember this number should be in this range if you want to configure the standard. If you want to configure extended, then number should be this range. So now we can use which number? We can use 10, 1, 2, 3 till 99 or use 1300, 199. Okay, so example I will use here 10. If I write axis list 10, automatically it is thinking about standard ACL. After that what I can say? I can say deny. So I will write deny. What I need to deny? One computer, right? As per our manager, I need to deny one computer. Which computer? This one. So I will write here deny host and give the IP address of that computer. So I will write 192.168.1.2. Okay, so what I am saying, axis list 10, I am giving the number as a 10, deny this computer. Okay, after that we need to tell allow also, because one more thing we need to remember, whenever we are configuring ACL, by default at last you will have deny statement. By default at last you have deny statement. If you did not allow the traffic, it will block all the traffic. Example I will write here axis list 10, deny this computer. After that, if I did not say allow the other guys, it will block all the guys because ACL is having the by default deny statement at last. Even if you did not configure deny statement at last, he will use the deny statement automatically. So we need to write permit all. If not, it will block all the traffic. So what I will do here, I will write same thing, AC axis list, and we will use same number, whatever number we give, 10, and I will say permit any, means anyone can go. So same thing we are saying, like if you remember just now what example we taken, here we are saying this is a office. Okay, this is our office. Okay, and here our security guard, and this computer come here. So our security guard checked this IP and he told deny. He did not allow this guy, but the other computer came, he will allow that guy. Okay, same thing we are doing here. First ACL is going to execute in the sequential order. So first command will execute this one. He will check if this is the IP of that machine. They will not allow the traffic to go this one. That's all. If other than this IP, they will allow that one. That's all. This is a two small statement we are writing. We are saying allow, deny this guy, allow all other guys. Means only one PC is blocked, remaining all PC will be allowed. After that we need to apply. Here we need to do two things. First thing, create the ACL. Create ACL. Then apply the ACL. Apply ACL. This is very important ACL because in ASA firewall also we will do ACL. If you go for Palo Alto, we are saying policy. If you go for checkpoint, if you go for FortiGate, all are having, but in the checkpoint, FortiGate, Palo Alto, we will do GUI. Graphically we can do. In ASA also we can do graphically, but most of the guy in ASA doing with CLI through CLI. But you need to remember ACL is very important. Wherever you are working, you will use the ACL in the real environment. So you need to practice more and understand the ACL. Okay, you have different name for ACL. In the ASA firewall we will call ACL, but if you look in Palo Alto we are calling policy, and what we can FortiGate and the checkpoint we are calling that one as a policy. Okay, so now what we are saying here, two things we need to do, create. So we created the ACL. Now we need to apply. How we will apply? We need to apply interface. Inside the interface we need to apply, because traffic is going here or leaving here. So we need to look the interface and apply to the interface here or here. Any one interface you can take. If you imagine, if you want to apply in this interface, then you need to think traffic is going in this way, like this way. So imagine this traffic is going into this router, right? If you are applying in this interface fast Ethernet 0x0, you need to remember going traffic inside to router. If you are applying here to the interface fast Ethernet 1x0, you need to remember traffic is going outside the router. So we need to remember, if we apply here we will write outside, if we will apply here inside. How we are saying inside outside? We are tracking the traffic. If the traffic is going in this direction, traffic is going into the router. That is why we are calling this interface. If we will say inside. If you see here, traffic is leaving the router, going out from the router. So we can say, if we use this interface, we will say outside. Okay. So what we will do here, first of all, we need to select where we want to apply. You can apply here or here, no problem. You can apply any one place. So I will apply here in the fast Ethernet 0x0. So I will write here interface fast Ethernet 0x0. First I need to go inside the interface, then we need to write IP access, then dash group and give the group number. If you see, this is the number which we use, so 10. So we need to write 10 here, and after that you need to write in or out. If you see fast Ethernet 0x0 is in, so you will write in here. If you go inside this interface, then you will write out here. So this is only the configuration. Okay, so now let's do this configuration in R2. Okay, excuse me. So how we will do, let me show here. Configuration, we write access list, press question mark, you will get which one you want to create. You want to use from 1 to 99, this is a standard. If you want to use this one, this is a extended. If you want to use, this is a different. We have so many here option. We can do Mac also, we can use for MPLS, but now our main focus to learn the standard extended. So I will write here 10. Okay, after that press question mark. They are saying what we need to do, what you want us to do, allow, deny, or you want to put some commands. So I will say no, I want to deny. So he will ask, okay, what you want to deny? I will press question mark. He's saying you want to deny complete network or one IP. So I will write I want to deny only one. So he is asking me give the IP of that guy. So I will write 192.168. What is the IP for that one? Let me check here. This one, right? 192.168.1.2. So 192.168.1.2. Okay. After that, what I need to do, I will write access list, same thing 10. I will write permit, and if I press question mark, he's saying you want to permit only one PC or complete network or any, what I need to do. So I will write permit any. This we created the ACL. If you want to check, you can write do show AC access, do show access list. With this way we can check also what we configure. If you see, we configure IP access list 10, we taken this number, and first we told deny this one and permit any, and this is a sequential number they are taking by default 10, 20, 30 it will come. So we configure this just now. Now we need to apply. So we need to apply inside where interface. So I will write interface fast Ethernet 0x0, because if you see this interface fast Ethernet 0x0. So how we will apply? First we need to go inside that interface, then we will write IP. We need to write IP access group, whatever the group number, we write 10. So I write 10, then this is input or output. So this is in. That's all. We apply the ACL now. Now we can go and we can check before the traffic. Before, where is the PC one? If you see, let me make big. Before this PC can ping, okay? Which one? This one I am pinging. So let me ping. I will write here ping. Okay, enable ping 192.168.1.2.2. okay. If you see now, request timeout, it is not unable to work. Before it is pinging, but now it is not working. Why it is not working? Because we apply the ACL. Okay, it is not working. Again check. It is not working. PC1 is not working. Now what I will do? I will go to the PC2. PC2 I will check now. Because we did not block for the PC2, so PC2 will work. 192.168.2.2. If you see, PC2 is working, but PC1 is not working. Why? Because we configure ACL, we are saying PC1 should not work, PC2 should work. Okay. So we done this lab. Let me show you what we done. We done one basic lab, this one. Configuration here I wrote the RIP, but this one we use the OSPF. Now just now what we use OSPF. Here if you see access list 10 deny, if I want to deny one IP, I will deny and I will go inside that interface and I will apply. If I want to deny complete subnet, I can do this way also. If I want to deny the complete subnet, access list deny, I can write here. If I want to deny complete subnet, I can give this way. All the subnet this way I can give. Access list 10 deny the network ID and then wildcard mask and permit this one and go interface and apply. So this way what I can do, I can block all the network 192.168.1.0, all network will be denied. If I want to deny, I can use this one also. Later we will see that one. So here I put the output, and if I want to check, we can check also. What we can check, we can write show access list, show IP access list. If I want to check the output, so let me go to R2 and we can check here, show IP access list, show access, show IP access list. Okay, so here if you see, here it is saying 32 match for, so 32 packets came and they deny, and 27 packets came, they allow them. Okay, so this way we can check our counter is increasing or not. If anyone is pinging, if it is deny, it will increase here. Okay, so this is a basic lab for the standard ACL. Standard ACL number 1. Later we will do the name one also. So let me stop this recording.